everybody. It's great to see so many bright young faces here today. My name's Anna. I'm a software engineer at Google here in Sydney. I work in the site reliability engineering team on a product called Google Photos. I'm going to tell you a bit more about that later. Today, I'm going to talk to you about what I love about computer science, what I love about my job. And the way I'm going to do that is I'm going to tell you a little bit about myself, about the opportunities that I've had, about where I come from, and some of the opportunities that might be available to you if this is a career and a line of work that you perhaps are interested in pursuing. So let's try this clicker out. My story. Cool. So I'm originally from Brisbane. You may recall it from all the cyclone warnings that we've seen all over the television recently. So I'm from Queensland. I perhaps had not a stereotypical upbringing for a computer scientist. So I didn't grow up coding from a young age. My parents certainly weren't in tech professions at all. They used a word processor at work like everybody else, but that was about it. I didn't grow up as a teenager playing games. I didn't run Linux. I'd never used a terminal or anything like that until I started at university. What I did really like, always, since I was a very young child, is puzzles. So I was the kind of kid who, if that was up on the screen, I'd probably find myself a little bit distracted. I'd be trying to solve that Sudoku puzzle. I don't know if there's anyone in the audience who's maybe finding themselves doing that, but that was me. So a lot of people who I work with have been playing with computers since they were very young, and that's a totally awesome background to have, and those are skills that are definitely valuable. But I hadn't. So I'd been doing Sudoku puzzles. I'd been playing cards since I was maybe 5 years old. It was always my favorite thing to do. So doing things which I now know could be thought of as algorithmic thinking and computational thinking. So things that involve breaking problems down into smaller pieces, things that involve abstraction, things that involve algorithms and numerical reasoning. I didn't know it at the time, but I now know this to also be a great and valuable base for starting a career in computer science. So I had an aunt who lived in New Zealand who was a computer programmer, and I'd see her once a year when we visited my family over there. What she taught me is that these kind of puzzles and these kind of games actually have a really interesting, meaningful, impactful outlet in computer science. So I went through high school and I did a whole range of different things. How old is everybody here? Who's in grade 10? A whole lot of you. Who's in grade 11? And grade 12? Okay, cool. So a lot of you haven't picked your senior subjects yet. Picking senior subjects was probably a pivotal moment for me. I knew I liked maths. I'd always liked maths. I did the regular maths course and the advanced maths course in Queensland. They're called Maths B and Maths C. I did English. I'd always liked English. I did history. I really liked the arts. I did chemistry because I wanted to keep my options open for medicine, and that left me with one free spot. And I was tossing up between physics and what in Queensland we call IPT, which is the programming course that teaches you a little bit about databases and a little bit about computational thinking and a little coding. And I think I could have gone either way, but perhaps as you're guessing right now, what I went for in the end was IPT. And I don't think I've looked back from that point. I found in that area somewhere that I could apply these skills, these puzzle-solving instincts that I'd always had and that I'd always liked, in a way that was fun, that was impactful, and that the industry and the people wanted. So I went to university. I went to the University of Queensland, again in Brisbane, and I was able to work on some really great things. So in my first semester, of year one, I did an Introduction to Coding course. It was in Python. Anybody know any Python? That's pretty cool. A lot of you do. That's awesome. I didn't when I went to university. I'd learned a little bit of Visual Basic in high school and a little bit of SQL, but Python and that style of programming was completely new to me. Every assignment in this course revolved around Sudoku puzzles. So it opened by trying to represent the structure of a Sudoku grid into arrays, and it finished with writing solvers that would solve Sudoku puzzles automatically. So for a kid like me, you can imagine how exciting that is. It felt like I'd come to a place which I knew I would fit in an area which I knew I would enjoy. As I advanced in my degree, I got to work on all kinds of maybe more complicated projects. So these pictures on the screen, they don't look very formal and professional because they weren't. These pictures both come from my university subjects. So the picture on your left with all the red dots, that came from a fun course that I did at university, where computer scientists and software engineers were paired with scientists from different disciplines where computational power was a benefit, was powerful modelling. So typically we were paired with biologists or with physicists. So I was paired with an astrophysicist. And what we had to do in this course is we had to replicate the results of a famous paper in that field using computational models and using parallelism and all kinds of high-performance computing techniques. So what that picture is it is the end result of that process, and we modelled the effect of a black hole in a triaxial galaxy, and the effect that had on the galaxy's shape. So modelling these big, huge forces out in space using the laws of physics that we know, and we can actually come to some really interesting conclusions there. Other people did models of evolution and some DNA modelling, and so it's pretty cool to be able to have a skill set, have a toolbox which is so useful, so immediately useful in disciplines that I know nothing about, because I have no background at all in astrophysics, say. Now, on your right is a picture that I put in my honours thesis. So in engineering degrees in Queensland, at least, in your final year, you spend a year writing a thesis in a particular area of your choosing. So my degree was in software engineering, but my thesis was in biomedical engineering, and specifically, it was in machine learning for medical diagnostics. So what we were looking at in my thesis was these cells that come from pap smears, which are used to detect whether women have cervical cancer, and trying to feed them to a machine learning algorithm to teach it what healthy cells look like and what suspicious, potentially malignant cells look like. So this machine learning is a collection of techniques and algorithms and models where instead of programming in our knowledge into a computer, we allow the computer to actually learn the structure of, in this case, pap smear cells, but a wide variety of different patterns and different knowledge that exists in the real world. So specifically in my thesis, we were using what's called a deep belief network. And one of the really cool things about a deep belief network is you can have a look inside its representation of the world, in this case, the world of cells, and see what it's learned. So we never programmed in those round cell-like shapes that you can see there. That's what it learned all by itself. So I think that's pretty cool. So I finished up at university with both a software engineering degree, but also with a Bachelor of Arts, actually. I always liked the arts. I majored in English literature in the end, but I also studied some art history, I studied some Indigenous studies, all kinds of valuable, exciting interesting things. I think there's a common misconception that people who are interested in computers are maybe interested to the exclusion of other things such as the humanities. That certainly doesn't run true for me or my experience of the people who I work with. So I had some great work experience opportunities while I was at university as well. I worked as a tutor in the maths department and in the computer science department, which was excellent. I love teaching and I love working with students. I did a summer research internship as well at my university. We looked at big algorithmic problems, distributed hashing algorithms, in fact, which was actually really exciting and really interesting. I learned a whole lot and got to present some interesting research and write some papers, which is really exciting. And I did an internship down in Sydney as well at Macquarie Bank, which was also a great experience. I learnt an absolute ton and met many people who I still keep in touch with to this day. So that's me up until I start at Google in 2014. So I said I'm a software engineer. The team that I work in is site reliability engineering. So what site reliability engineering is instead of building new features that you might see, we deal with back-end problems of efficiency and scale and reliability. So if you've ever seen on maybe a bank website planned downtime for maintenance, or if ever you've maybe gone to, often it happens at kind of the Boxing Day sales for online retailers, for example, they say server overloaded, try again later. I'm sure many of you have seen them for external sites, but I bet very few of you have seen that for google.com or photos.google.com or maps.google.com. And that's because we have really sophisticated site reliability engineering and employ lots of people like me. So we're software engineers, we're building things, and we're building solutions to dealing with this massive scale, dealing with hundreds of thousands or even millions of requests coming in every single second. So site reliability engineering is where lots of the really interesting problems, I think, in computer science lie. So I'm really proud to work as part of that team. Specifically, I work on a product called Google Photos. Has anybody used it? Oh yeah, we got some hands. That's awesome. I think it's a really great product. Google Photos backs up all your photos from an Android phone, from an iPhone, maybe photos you have on your computer, and it stores them reliably in the cloud so you can access them anywhere you want. And it does all kinds of really clever, sophisticated machine learning on those photos to do image recognition. So not dissimilar to the sort of stuff that I was doing in my honours thesis. So it lets you search through your photos. This is only available to you. Of course, it doesn't make it available to the public or to anyone on Google Images or anyone who works at Google, of course. But it does let you search through your own photos for things like, well, for me, it's often show me my photos of my dog. And I haven't tagged them as my dog, but it can recognize from within a photo what shows a dog and what shows something else. And then when you combine that with the metadata in photos, you can ask really great questions like, show me my photos of my dog at the beach, or show me my photos of my dog at the beach in 2001. And it can pull that kind of stuff out. So that's pretty cool. So I've had some great experiences at Google. I consider myself really lucky to have had that as my first job. I've been there for 3.5 years now. So a little while. I've met some great people. I got to talk to Bill Shorten about the National Computer Science curriculum. Up in the top right corner, that's me with Anita Sarkeesian, who's been a long-term hero of mine, so really, really cool to meet people like her. Down at the bottom, there's a cheesy photo of me with my thumbs up. This is on my first week at Google. I was in the US at the Mountain View headquarters, the main campus, and that guy in the pink shirt, who probably doesn't mean anything to you, His name's Peter Norvig, and he wrote the textbook on artificial intelligence, which is used at just about every university that I know of, and he's a complete superstar for people who are in that area. He works at Google, and that's my first week, just noticing him sitting at the same cafe that I was sitting at. I must admit, I was too nervous at that stage to go up and say hello, but maybe that would change today. So I consider myself really lucky to be working at a place where I can rub shoulders with some people who I really admire, with people who influence how our world is shaped today and build some of the technology that's going to make a really exciting future possible. So I think that brings us to what I told you I'd talk about, what I love about computer science. And I hope hearing a bit about the opportunities that have been afforded to me and the kind of things that I've been able to explore help you kind of understand how I come to these points. So first of all, computer science is broad and impactful in really diverse fields. I know nothing about biomedical engineering and I know nothing about astrophysics, and yet I could work on projects that were doing meaningful, exciting things in those disciplines. Throughout my relatively short career, I've been able to work in finance. I've been able to have some experience working in academia. I've worked for a Silicon Valley tech company and done all kinds of projects in different disciplines. I think computer science is, it's been said already today, is going to be shaping every industry in the next 10, 20, 30 years. Some of the big breakthroughs in medicine are not going to happen just because of medical researchers. They're going to happen because of data modelers and computer scientists. So I think that's an incredibly exciting place to be. Secondly, computer science is in demand and the jobs are great. We've heard this talked about already today, the idea of supply and demand. We don't have enough supply of computer scientists at the moment, and we have lots of demand. And what that translates to is people fighting over you, which means really nice jobs. So jobs that are well paid, but perhaps more importantly, jobs that respect you and treat you really well. I have many friends who are young lawyers or young people working in finance. And the expectations in those kind of industries is that you put in these extremely long hours and you work yourself completely to the bone. But the people I know in computer science actually really like their jobs. They have jobs that are fun and exciting to them, where they can go home at the end of the day at a reasonable time and do whatever else they want to do. So work-life balance is something that computer science has to offer that I think is about the most valuable thing out there. Thirdly, computer science is global. So in my role, I go to the States once or twice a year. I've been to Europe maybe 3 times with work. I was in Shanghai just a couple of weeks ago. I'm lucky to be able to travel so much, but that's not so unusual in computer science industries because they are so global. Being able to translate your skills and take them to different countries is an awesome thing. If you decide you want to work in America, or you decide you want to work in the UK or in China, or really anywhere that takes your fancy, computer science is about the best background you can have. And finally, computer science is about solving problems and creating things. So you actually get to see the impact of things that have come out of your head and that people are using all around the world, sometimes hundreds of thousands or millions of people. So I think that's pretty special. So, as promised, I'll have a few minutes for questions, but the message I want to leave you with is that there are all sorts of people in tech from all sorts of different backgrounds, and that they work on really a totally incredible array of different projects in different fields. So thank you. Now, thanks. Okay, does anyone have any questions? So the question was a great question, was what kind of jobs can a computer scientist have at Google? And you said that I mentioned that there were jobs in Silicon Valley, but are there other more diverse areas where you can work? And the answer is absolutely. So there's a whole lot of jobs that are engineering jobs specifically. So I'm a site reliability engineer. Many people are pure software engineers. So they build products. They might be web products. They might be Android products. Many people work in testing. And then there are all kinds of jobs in people management and product direction. So Google is a bit special, though I think it's a common practice in other places that all of our management team, all of our product managers are also software engineers. So they're also trained in computer science. You can work all around the world. So you mentioned Silicon Valley, and we have many people in Silicon Valley, but we have a lot of people in Sydney too. We have a lot of people in Zurich, in Paris, in London, in Dublin, all around the States, a lot of people in New York, a lot of people in Singapore, a lot of people in Japan. You name it. There really are a lot of possibilities. Cool. That's a great question. So the question was, given that I came to tech at the end of high school, did I find university difficult? I think that the answer there is yes and no. So universities don't expect you to have been doing it since you were 13 years old. They are teaching you from the ground up. I think the biggest issue is actually confidence. That often if you're in a room with people who already know maybe a lot more about you than something, it's easy to just sit quietly in the back and just follow along. So I think that's something that you have to consciously fight against, because it's absolutely possible to make a late career switch into software engineering. I have friends who've done that in their mid-20s quite successfully, actually, from a guy who was studying law, for example, or a guy who was studying chemistry, I know, who have great careers now. Yeah, look, there's lots of people who want to work at Google. The interview process is long and quite intense. But I guess the thing there is that you never know until you try. I didn't expect to be hired, and yet I was, and it's worked out so great. And I think that's a common story. So you got to be in it to win it.